Here we go. All right. Well, hello, everyone, and thanks so much for joining us. My name is Dawn Hansen. I'm the Executive Director of the Bulkley Valley Research Center. We are so thrilled that we are able to offer these seminars virtually and to have so many people be able to attend. It really has been a positive, phenomenally amazing outcome of finding ourselves in a pandemic situation and being tasked with working in creative ways to move to different systems. I'm hosting from Gidimt'en territory of the Wet'suwet'en Nation, and place of hopefully some old growth forest left. Karen can enlighten us on that a little bit in a moment. And our presenter today is Karen Price on BC's old growth forest, a last stand for biodiversity. And Karen Price works at the interface of science and management with her partner, Dave Doust. Recent work has been focusing on assessing risks to ecological values posed by cumulative effects of resource management and climate change. She's been involved with old growth forests for 25 years. And frustrations with lack of transparency in policy inspired her, Dave, and their colleague Rachel Holt to analyze the condition of BC's old growth forests. Karen, it's great to have you and your presentation today. Thanks very much.
Thanks, Dawn. Okay, so yeah, I'm going to be talking about the condition of BC's old growth forest. My first slides go pretty quickly, and I don't know if they will go quickly for you. They may get hung up because I have very poor internet here. So I may be speaking about something that you can't see, but we'll deal with that. And then later on, it'll get easier because the slides are slower. So we know that old growth is disappearing globally with implications for biodiversity, ecological resilience, and climate change. But we don't seem to know how much we have. So the story is different depending on who you talk to, whether it's industry, whether it's government, whether it's environmental groups, whether it's First Nations. We have different answers. And it turns out that it depends on your definition of old growth, unsurprisingly, perhaps. So that's going to be the focus of my talk today. So here's the outline. We're going to talk first, I'm going to go through the concepts, why do we care, do a kind of pictorial quick view of why old growth matters, and then talk about the study. So how much do we have in BC? Definitions, numbers, maps, what's our risk of biodiversity, and how much do we have conserved? And then I'll end up with the politics. How did we get here, and what's happening from now? So old growth is more than just majestic trees. I don't know if you guys can see, but I've got a slide here that's got trees on it. Old growth is a community, we're good, are we? Okay. Old growth is a community of trees and other plants and animals and fungi and microbes who have lived together for long enough that they've developed an interconnected web that can communicate and share resources. And this long time period gives enough time to develop complex structure, which can include massive trees, large dead snags, and long pieces of downed wood. So rather than the open warmth of recently disturbed forests or the dark kind of biological desert of a young mid-seral forest, old growth has dappled light. It allows shrubs and herbs to grow and increase the complexity. This complexity provides diverse homes to a whole bunch of organisms, from rich communities of soil microfauna to unique canopy communities, a number of species that people care about, and a variety of other organisms, from some generalists to specialists. Many of these specialists are rare. So with biodiversity, it's important because old growth acts as a living sponge, so it takes in the water from the rain and the fog, and it filters it, and then it releases it slowly out into above and below ground systems. Intact forests can ameliorate both flooding and dry season low flows. And when you walk in the forest, pretty much everything that you see is storing carbon. So we have massive amounts, particularly in temperate rainforests, up to 1,000 tons per hectare of carbon stored in these forests. And if we want to think about climate change, then really the best thing we can do is leave any of these wet productive forests standing. Way better than planting. We can't plant enough trees. It doesn't matter how fast they grow. They're not going to replace this carbon. So as well as climate mitigation, old growth can also help us adapt to climate change. So old growth stands, it turns out, resist wildfire. Some people, like those folks in BC Wildfire Branch, might be surprised by that. It also, like I said, it helps with floods, provides, it's a buffered microclimate, and also provides refugia for organisms to redisperse after disturbance, which is particularly important in BC because we have quite a high proportion of kind of macro refugia. So old growth, my summary, it's special, it's important, it's rare, it's threatened. And importantly in BC, BC's forest policy actually relies on old growth. This is our strategy to maintain biodiversity. That's why old growth matters. So let's look at the study. And as Dawn mentioned, Rachel and Dave and I have been all working in old growth for decades, and we've all done reports for the provincial government, and these reports have not been released. And so we just decided we're going to take this into our own hands. The data became publicly available. So we took it, we analyzed it, we released it, and it's been quite a fascinating process over the last year. We released this in April, and you know, I've never had any publication get the interest that we've had with this report. We have people from around the province getting in touch with us more than weekly, you know, sometimes daily. So we're working with people all over the place who are saying, so what can we do in our area? What does our area look like? So that's really exciting because there's kind of a groundswell. It will be published. I'm working on revisions right now, but it's been accepted with revisions. So we're happy about that. Now, I said at the start that definitions matter, so let's start there. For old growth, we'd really like to be able to define it functionally. However, that's tricky. Ecosystems differ. We don't have a system in the province. And forest management uses simple, somewhat arbitrary age classes, where wetter forests are defined as old over 250 years, drier over 140, and boreal over 120. And partly because we don't have a better definition available, and partly because we wanted to mirror what the province had analyzed, we use these provincial definitions. Interesting thing is in BC, these are also primary forests, not true for much of Europe because here industrial forest has only been going on for the last century. More important to my presentation, so just whenever I say old growth, what I mean is forest above a certain age, so we're clear on the definition. So now let's think about how we're going to define old growth type. And we use two different systems here. One is we use Biodiversity Variant, which gives us an idea about what an ecosystem looks like based on landform, based on temperature, based on moisture. And the second one we use is site productivity. Now the first one, I think probably I'm guessing that everybody who's watching is familiar with a Beck map and is quite comfortable with knowing that the forests along the coast here, coastal temperate rainforest, and that the coastal western hemlock is quite different than the inland rainforest, quite different than the subboreal spruce, where I am right now, and quite different than the drier forest in the south. So we use Becks Variant, and that's what the province uses to look at old growth. The thing is that within variants, forests differ greatly. So these three pictures here are all in temperate rainforest. This is a bog near Prince Rupert, and then these two are inland rainforest, kind of moderate productivity, high productivity. You can tell how different those are. So imagine yourself on the coast somewhere, and you're going for a walk, and you're walking along a valley, and there's these like massive, way bigger than that, Sitka spruce, depending on where you are, Douglas fir maybe, and then you come out on a rocky knoll, and there's these little spindly shoreline. Same Becks variant, very different ecosystem, different function. Let's say you're in the boreal, you're going through black spruce muskeg, and all of a sudden you come to a patch of white spruce and cottonwood in the valley. Very different. Even when you go hiking and you climb up the mountain, you know that you're in the Engelmann spruce of alpine fir, at least if you're around here. And the trees at the bottom can be massive, and the trees at the top are tiny. Same Becks variant, different ecosystem. Now, I don't want to say that productive forests are more valuable. Well, I kind of do, but Lower productivity forests are also important. So, you know, if we look at this bog down here, it's got all sorts of unique things that live in it. Important biologically, totally important. The point is that they're all different. They all have different functions, and we need to maintain all of them if we want to maintain ecosystem representation, which is the fundamental principle of conservation biology. In addition, productive forests, because of the massive structure at all scales, they tend to be biodiversity hubs, carbon banks, and climate change refugia. So maybe they do have a little bit of extra importance. So we looked at productivity basing, we based our classification here on timber inventory methods. We used site index, which is the potential tree height at 50 years. So if I say site index is 10, that means that in 50 years, a tree is 10 meters tall in 5-meter classes. And just to give you an idea of the range, for those of you who aren't familiar with this, if there's site index less than 5 meters, essentially this is excluded from our forested land base. It doesn't count as forest. Once we get to a tree that's 5 meters or above, it gets put in the forested land base. But trees that are on sites where they don't beat 10 meters in 50 years are rarely economic to harvest. If we look at productive sites in the interior, the most productive are kind of 20 to 25. And if we look at the coast, then they're greater than 30. So this means that in 50 years, a tree has the potential to reach 30 meters. So there's our 2 classifications. We looked at 3 scales, the whole province, within Becks units, mostly within variant, sometimes grouped into zones. And then we also looked at Becks Variant within landscape unit, which is the unit the province uses to manage forests. And at each scale, we looked at how much old growth is there with and without productivity to see how much of a difference it makes. We looked at the total amount of old growth, and we also looked at the area of old growth as a percent of what we would expect there under historic disturbance regimes. So that gets us to how much? What is there? How much do we have in BC? They're at the provincial level. So the government claims that we have 13 million hectares of old growth in BC, which makes up about a quarter of BC's forests. On this map here, the old growth is dark green, other forest is yellow, and non-forest is gray. Now, when we analyze the data, we go, yep, there's about 13 million hectares. We don't dispute that. So, I mean, it's a good thing that our data, our numbers agree. What the government didn't say is that 80% of this area supports smaller, tiny trees, less than site index 15, and it includes subalpine and bog forests that most of us would not think of as old growth. But most people wouldn't, maybe ecologists would. So we said, okay, let's remove the smaller. So let's only look at commercial trees, so above site index 10. And so now let's look at the green on this map. So now we're looking at trees site index 10 and above. And so once we exclude this, we lose 5 million hectares. So we're down to 8 million hectares. And then we say, okay, how about productive forests? How much do we have? So if we look at site index above 20, these are forests that have the best potential to grow large trees, although others can, given enough time. We're down to, I mean, look at this map. Can you see the green? There's not a whole heck of a lot. There's some up top here. I think there's some in Strathcona Park. There's some little bits around, but unless we blow it up to a bigger scale, really hard to see what's there. So the point here is that the government claims that 25% of BC's forests are old growth. They're not wrong. However, less than 1% of BC's forests are productive old growth, which is the type of forest most people think about when they think about old growth. Now, a lot of you are probably going, well, yeah, we don't expect everywhere to have big old growth. Well, of course we don't. So not all forests in BC can grow large trees. So let's look at the proportions here. So this is the pie graph that I've got here. The size of the pie represents how much area there is in BC with a particular site index, so with the potential to grow big trees. And you can see that most of BC has the potential to grow small or medium-sized trees and a small area to grow these productive trees. These are rare ecosystems anyways on the landscape. But the important point is to look at the green pieces within the pie, and this is the proportion of old forest within each site index group. what you can see is that the proportion decreases. So when we're looking at the littlest sites with the potential for smallest trees, the low productivity sites, we've got about 36% old, which is about what you'd expect historically. But as we go through, you can see that the size of the segment shrinks until we get less than 3% in the highest productivity class. So we've lost old growth as we increase productivity. Let's see how that looks when we divide it a bit more finely. And so now let's look within Becks Variant. And for our talk today, I've combined this into zones. Some of the zones are divided because they have different ages of old. And here you can see I've got zones across the bottom, and then low productivity is in light green, high productivity is in dark green. These bars here, the green floating bars represent the amount that we would expect under historic disturbance. So the coastal western hemlock and mountain hemlock, we expect to have more than 80% old under these conditions. Most of the others somewhere between 25 and 40%. So the first thing to notice here is, oh, look, we have the same pattern. And, you know, this is, here I'm looking at the percent of each site index group that's old. So this isn't amount, this is percentage group. And what you can see is that the percent of low site index groups are high, and the percentage of high productivity sites is low. You know, in a lot of cases, we're down to definitely less than 5%. So this is the same pattern if we look within Becks Variant as across the province. A few things to point out. There's some zones where there's just very little old forest and any productivity. So the coastal interior Douglas fir and ponderosa pine, low elevation, easy access to people. We've really lost most of that. I want to raise the specter, I guess, of data issues. Yes, the data sucks. However, it's the best that we've got available. And so we're working with what we've got. One thing to point out here is that we're probably, definitely, underestimating the amount of old forest in high elevation, poor productivity ecosystems, because age is taken from estimated from air photo interpretation. And so if you've got a really poor productivity site, it's really easy to say it's not as old as it really is. So yes, we are expecting within these ecosystems, particularly the wet ESSF, the mountain hemlock, that we actually have a lot more low productivity than we see here. And then I want to bring attention here to the boreal forest. And you can see that this one actually doesn't decrease that much. And it has about the amount that you would expect under historic disturbance conditions. So what's going on here? Well, the age is lower here at 120, but that really shouldn't matter. We're comparing it to the amount you'd expect at 120. There's a big deciduous component in there. And yes, there's parts of northern BC in the boreal that haven't been logged yet. So those are reasons why we have more there. The other point I want to make with this area is that our data cannot tell us anything about ecosystem condition. We're just looking at amount. And the issue with the boreal, as you know, is in northeast BC. Yes, we've got old forest, but we have this extensive road and oil and gas network that means that very little forest is any distance from a structure, from a linear structure. And so we've got changes to the condition depending on that. Not dealing with that here today. So that's how much we've got. Now what we saw at the province and within Becks Variant is that the amount of forest in high productivity sites is much less than high productivity sites. So than low productivity. So these high productivity sites, what's going on there? What's the potential risk to forest biodiversity for the organisms that depend upon these forest types? And here we've used an approach that's used across BC. That's looking at how much habitat there is left. We go from 0 to 100 on the x-axis, and then looking at how much risk that poses to biodiversity. And this curve is based on a meta-analysis of habitat thresholds. So as we decrease habitat, there's less and less habitat, there's less space for organisms, so you expect population to go down. But sometimes you reach a point and it crashes. And that's a threshold point. And thresholds are ecologically important because they can be indicators of where function has changed. So it's not just that there's less habitat, but something's happened. Maybe the patches are too far apart for critters to find partners. Maybe they're too far apart for pollinators to get to the next patch of flowers. So there's the potential for ecological function change, and we may not be actually able to get back up to here. So that's why thresholds matter, and we want to, if we want to maintain ecological integrity, we want to try and not cross thresholds. And the literature suggests that if we're above 70% of habitat, then very few organisms cross thresholds. Not none, very few. And if we have less than 30% of habitat that we would expect, many, many do. And here, you know, not all dandelions don't seem to ever cross the threshold, but the important point is that specialists do, most specialists. So if you're an old growth specialist and you've got less than 30% habitat, you're likely not doing well. So we have an S-shaped curve, more uncertainty in the middle just because critters are different. I shouldn't just say critters, organisms are different. So uncertainty bands are wider. But this is what we use. And so what I'm going to show you now are some maps where we have looked at the finer scale. So we're now looking at Becks Variant within landscape unit. And we're saying, what is the proportion of old forest out of what we would expect out there? And what does that tell us about risk? So if there's less than 30% of what we'd expect, it's colored in red. More than 70, colored in green, yellow in the middle. So here we are with all forests. You can see a map of risk biodiversity across BC. And like this whole red thing up the middle, it doesn't mean it's all been logged. A lot of it has, but this is also cumulative effects of mountain pine beetle and wildfire, much of which has been subsequently salvaged. Now let's go to the commercial trees up to site index greater than 10. You can see that the red is spread. We have fewer places that are green apart from up the north. Now let's go to site index greater than 15. And now you start to see, well, it's getting, there are very few landscape unit Beck combinations where we still are at low risk. And I'd like to point out a couple of places down here in Vancouver Island. This is Clayoquot Sound. And here's the Great Bear Rainforest. And you can see at this scale, because management is different there, we actually still have ecosystems, coastal ecosystems at low risk. But once we get to site index greater than 20, these productive ones, we've really turned a lot of the province red. So Clayoquot Sound doesn't have a lot of these, at least you can't see them at this scale. Great Bear Rainforest, there's a lot of landscape units that don't even have any forest greater than site index 20, no matter how old. So that's what risk looks like across the province. Let's look a little more closely. So if we look at the landscape unit Becks variants that are colored in red, so these are the ones with less than 30% of what you would expect, not less than 30% total. So let's say you'd expect 30%. We've got 30% of that. So we're looking at 9%. No, we're not. We're looking at, yeah, whatever. So we're down to small proportions here. So let's look at that. And if we look at the amount of all forests, what we can see is that 41% of these units, landscape unit by Becks variant, have less than 30% of what we would expect. And about a quarter have less than 10% of what we would expect. So if we expect 30, we're down to less than 3. Now let's look at the productive. So we're just looking at the ones with site index above 20. And you can see that almost all of them have less than 30% of what you'd expect. And 43% have less than 1% of what you'd expect. Now I want to pause here and have that sink in. 43% of productive old forest ecosystems in BC have less than 1% of what we would expect. High risk is 30%, 1%. Moving on from risk, what have we done to conserve old forests? And here we looked at areas that are no harvest, so parks and protected areas, obviously conservancies, and there's also wildlife habitat areas with no forest harvesting, and we also included spatialized legal old growth management areas. Even though there are a number of kind of loopholes that let you log in there, we've included those. And in BC, we're actually doing pretty well for no harvest areas. If you look at the gray bar, you can see we've got 23 million hectares of protected forest or protected area. That's about a quarter of the province. Sounds really good. But now let's look at that. More than half of that isn't even forested. It makes sense. A lot of our big parks are high elevation. But if we look at, if we're interested in forests today, then we're looking at less than 10 million hectares that have forests of any size on them. And a portion of that is old. If we look at the commercial tree size, so site index greater than 10, then we've dropped down to about 6 million hectares. And if we look at the productive forest, site index greater than 20, we can see that we're down to 500,000 hectares. And the old forest, the dark green, it's there somewhere, but you can't see it. So in this no harvest area, we have about 100,000 hectares of productive old forest protected in any of these ways. Let's look at what that looks like on a map, and you'll see why it's so little. So, I mean, I always think that BC's got lots of protected area, but you can see that these gray areas here, these are the protected non-forest. So we actually have quite a lot of protected non-forest. Awesome, I like having protected areas, but it's not doing anything for forest biodiversity. And then the dark green, the green areas are areas of protected forest. The light green is site index 10 to 20, and the dark is the really productive. So you can see like Tweedsmuir Park here, we have quite a nice section of protected forest of kind of moderate productivity. Strathcona, I think, arrow seem to work. There we go. Strathcona has some high productivity as well as some moderate. And, you know, we actually have some decently high productivity up north in the valleys. We do have some protected, but very, very little. And if we think about our international targets for biodiversity, we're supposed to reach a target of 17% of representative terrestrial ecosystems. That's what we agreed to. And productive forest is a type of ecosystem. And if we want to reach our target of 17% within productive forest ecosystems, we need to add an extra 350,000 hectares to that 108,000 hectares that we have. Now we can add, there's still high productivity sites in there. A lot of it's not old, all the stuff in here. But we do have some old that we can add, and we also have some that's not old. So we could actually reach our target if we wanted. So that's an interesting point. So to sum up, how much old growth? This is the study part. Productive old growth forests almost gone. While a quarter of our forests are old, less than 1% are productive and old. So 415,000 hectares out of 50 million hectares of productive old growth. And importantly, nearly 90% of these productive forests have less than 30% of the amount expected to be old. And over 40% have less than 1% of the amount we expect to be old. And these amounts pose high risk to biodiversity, ecological resilience, and carbon storage. We have about 100,000 hectares of productive old forest protected, but if we want to maintain function, we need to improve this. We are not achieving ecosystem representation, which, as I mentioned earlier, is the cornerstone of any conservation strategy. We're doing very poorly with these forests. So how did we get here? So this is the politics piece. And what we got here, probably not surprisingly, because policy prioritizes timber. So timber comes first. So let's have a look at the regulation for the objective for biodiversity. You'd think this would aim at protecting biodiversity. Okay, but what it says is the objective, blah, 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 for biodiversity is without unduly reducing the supply of timber. Now it's like, hang on a sec, this is a biodiversity objective. But no, timber comes in there. So even though our legal language has a whole suite of values that we're supposed to be maintaining, we're only able to maintain those as providing that they don't unduly reduce the supply of timber. And policy tells us that an undue effect is anything more than 4%. So we can only have a 4% impact for biodiversity on the timber supply. To meet this 4% cap, government worked on a whole bunch of modeling stuff and moved from the biodiversity guidebook to landscape unit planning guide, a whole bunch of history stuff there that I won't get into the details, but they did some things that they told people about. In low biodiversity areas, they reduced the targets by 2/3, called the drawdown. So if the target was 12%, now it's 4%. Some things were hidden. They double counted parts, they got removed off of the targets and got removed a second time in implementation. More important for today, for the talk today, is that they ignored ecosystem productivity and instructed industry to place old growth management areas where they didn't want to harvest. So here's the policy wording. Representation must be calculated. Note the must, not can, this is a must, at the variant level only, unless it's a higher level plan. So you can only look at Becks Variant. You cannot look at productivity. You are not allowed to. You're not allowed to do the analyses we did. When we've analyzed stuff for the province, unless First Nations have been involved and said, look, we're going to look at productivity, we are not allowed to in our reports. You may not. And you must meet your old growth target. And again, there's a must, using the non-contributing land base. So you're putting them where you don't want to log. What this means is you can harvest a small portion of a watershed and take all of the productive forest. Here's an example of that bias. So here's a watershed on the coast. And if we look at the map on the left here, the darker colors are more productive forest. So dark red, middle pink is moderately productive, and the light pink is low productivity. Dark brown is higher, light brown is lower. And we don't actually, I think this is the only bit of light green. So just look at the darkness of the colors there and think that those are the high productivity sites. Here's a map of forest age. The yellow pieces are young, less than 20 years old. These have been recently clear cut. The light green is 20 to 40, so that was clear cut before. Now, take your eyes back from one to another and see how closely they match. So while this watershed has a lot of old forest in it, all of this dark green stuff is old growth. All on the hillsides and the valley bottom with all of this productive forest has all been logged. So essentially what happens is that our policy is leaving us with the guts and feathers. And like I said at the start, it's not that we're saying the low productivity forest doesn't matter, it does matter. Guts and feathers matter to a bird, they need them. But they don't make a bird. If we want to have ecological integrity at landscape scale, we need to keep all of the pieces. People were getting concerned because, I mean, you know, people have known this. It's not like we're telling something new. It's just that we've put together the numbers in a way that has spoken to people. And we did it in time to inform this old growth panel that the government had convened, because around the province, everyone's going, what's going on? And these guys, I think they did a really good job. They talked to people around the province. They came up with 14 recommendations. A big one is that they're going to change the paradigm from what we talked about September 1st, from a timber-based focus with ecological health as a constraint to an ecological-based focus with timber as one of many benefits. This is foundational. If we don't do this, we're not changing anything. They also talked about developing science-based targets, so this would be considering risk, perhaps. And importantly, stop the bleed. So defer development in old forests where ecosystems are at high near-term risk of irreversible biodiversity loss. And they agreed with our report that productive forests are one of these classes that are at high risk. What did the government do? Well, the previous government released a response, and there was no mention of the paradigm shift or the new targets. They did defer a harvest on 353,000 hectares. And if you remember, I said what we need is to protect an extra 350,000. It's like, oh, you go, oh, cool, look at that. They're deferring harvest, not protecting, but deferring for 2 years harvest on this area. And we go, oh, this sounds pretty good. But then once we had access to the data, we looked at it more closely, and look at this pie chart. So of this 350,000 hectares, gray piece here, more than a quarter of it is not forest. They say this is deferral of old growth forest. Okay, a quarter is not forest. Another quarter, the yellow bit, is forest, but it's not old. It includes clear cut. It includes second growth that's open to logging. That's what the order says. So that leaves half of it that is old forest. And we go, okay, we've still got half, looks pretty good. But once we look at it, a lot of those areas are already in no harvest zones. So they're not being deferred. There's no need to defer them. They're not currently threatened. And a lot of them are not productive. So if we start looking at it, only 3,800 hectares. So see this little green piece at the top? That's the amount that's productive old growth that's not already in a no harvest zone. 1% of this 353,000 hectares. So this is the part that the old growth panel said we need to defer. We got 3,800 of it deferred. Doesn't seem to be a big bonus. And I mean, I know there's reasons and things had to happen fast, but it wasn't what we were hoping for. So now we have a new government. The first thing that happened was the mandate letters that went out to ministers, and the mandate letter to Minister Conroy claimed that this 350,000 is all old and that it's all protected. This again was a little bit disturbing because they knew, people had told them that this was not true, but we're hoping that this is fixed now. And I think the big opportunity is with land use planning, and we know that Nathan Cullen is going to be working on that. And this gives an opportunity to change things, perhaps include old growth. We know there's land use planning happening in the province already, particularly in a number of collaborative First Nations provincial government endeavors. This I see as kind of the biggest hope I've seen in 25 years. But, you know, there's still pressure, and Nathan says this, there's pressure for jobs, there's pressure for industry as we harvest the last old growth in the next 5 to 10 years. I mean, 5 to 10 years, the mills will run out of old growth anyway, productive old growth. If we stop now, we still keep a little bit for biodiversity, potentially. Problem is that we just don't have a lot of time to talk and log, and I'll just give you a sec to read this cartoon. And if we don't do something now, we'll move from the current condition map, this is of commercial sized trees, site index greater than 10 that you've seen before, to a future projection. Won't quite be this bad because we haven't modeled Clayoquot and Great Bay rainforest in here, but essentially we're moving to high risk across the province. And our old growth forests will be gone, and forests across BC will be gone outside of parks, I should say. High productivity forests around BC will look more like this. So this kind of closed canopy, second growth, young, mid to mature forests. And rather than this, the variety, the complexity, the functionality, the biodiversity, the climate change, adaptation, mitigation. And this is why I, this year, moved from being a scientist to being a scientist who is advocating for change, because I feel it's my responsibility to speak out. Thank you. That's the end of my presentation. I don't have a clue who's out there, and I can't hear anybody wild cheering or whatever.
Thank you, Karen. What a phenomenal presentation. Thank you so much.